Imagine a world where robots not only perform tasks, but also think, learn, and evolve an intelligence so profound that it rivals the human mind. Welcome to the future of AI, where we stand on the brink of achieving the ultimate breakthrough: artificial general intelligence. This is the story of how we got here, a journey through 10 revolutionary stages that have transformed machines from simple rule followers into potential pioneers of the next era of intelligence. But before we start, please make sure to subscribe and turn on the bell icon for more updates. Let's dive into the video. Number 1. Rule-based systems, expert systems. The first significant step in AI development was the creation of rule-based systems, often referred to as expert systems. These systems were designed to mimic the decision-making abilities of a human expert within a specific domain. By using a vast database of rules and conditions, expert systems could analyze data and make decisions or recommendations. Here's an example. One of the earliest and most famous expert systems was Mycin, developed in the 1970s to diagnose bacterial infections and recommend antibiotics. Although Mycin never made it to clinical use, it demonstrated the potential of AI in healthcare. These systems were limited by their reliance on predefined rules, which meant they could not learn from new data or adapt to new situations. Their utility was confined to well-defined, narrow tasks. Number 2. Machine learning. The advent of machine learning marked a fundamental shift in AI development. Unlike rule-based systems, machine learning algorithms can learn from data without being explicitly programmed. This capability allowed AI to handle more complex tasks and improve performance over time. In the 1990s, IBM's Deep Blue, a machine learning-based chess program, famously defeated world chess champion Garry Kasparov, highlighting the power of AI to learn and adapt to competitive environments. Machine learning opened the door to applications like image recognition, natural language processing, and recommendation systems, which are now ubiquitous in modern technology. Number 3. Deep learning. Deep learning, a subset of machine learning, further advanced AI capabilities by utilizing artificial neural networks with many layers, hence the term deep. This approach allows AI systems to process and learn from large amounts of unstructured data, such as images, videos, and text, with unprecedented accuracy. Google's AlphaGo, which defeated the world champion Go player in 2016, was powered by deep learning. Go, with its vast number of possible moves, had been considered a challenging game for AI, but deep learning made it possible for AI to master it. Deep learning has revolutionized fields such as computer vision, natural language processing, and autonomous systems, making AI systems more capable and versatile. Number 4. Robotics integration. As AI matured, integrating AI with robotics became a natural progression. Robotics integration enabled AI to interact with the physical world, giving rise to autonomous robots that could perform tasks ranging from simple assembly line work to complex surgeries. Boston Dynamics robots, such as Atlas and Spot, demonstrated the integration of AI with advanced robotics. These robots can navigate complex environments, perform dynamic tasks, and even interact with humans, showcasing the potential of AI-powered robotics. While AI-powered robots have made significant strides, challenges such as real-time decision-making, safety, and human-robot interaction remain critical areas of research and development. Number 5. Reinforcement learning. Reinforcement learning is a type of machine learning where an AI agent learns to make decisions by interacting with its environment, receiving rewards or penalties based on its actions. This approach is particularly well suited for applications where decision-making is complex and involves sequential steps. The success of OpenAI's Dota 2 bot, which defeated professional players in a complex multi-agent game, was largely due to reinforcement learning. The AI learned strategies and tactics through millions of simulated games, improving its performance iteratively. Reinforcement learning has found applications in autonomous driving, robotics, gaming, and finance, where AI systems need to make real-time decisions in dynamic environments. Number 6. Natural language processing and understanding. The ability to understand and generate human language is a critical aspect of AI's evolution. Natural language processing and natural language understanding have enabled AI systems to interact with humans more naturally, making them more accessible and useful in various applications. OpenAI's GPT-3, a state-of-the-art language model, can generate coherent and contextually relevant text based on a given prompt. It has been used in applications ranging from chatbots to content generation. NLP and NLU have made AI more user-friendly and capable of tasks such as translation, summarization, sentiment analysis, and conversational AI, bridging the gap between humans and machines. Number 7. Cognitive and emotional intelligence. The next frontier in AI development involves imbuing machines with cognitive and emotional intelligence. This stage aims to create AI systems that not only understand data and logic, but also recognize and respond to human emotions, making interactions more empathetic and effective. AI companions, such as Replica, use NLP and emotional recognition to provide users with emotionally intelligent responses, simulating conversations with a caring and understanding friend. Cognitive and emotional intelligence in AI could revolutionize areas like mental health support, customer service, and education by providing more personalized and human-like interactions. Number 8. Autonomous systems. Autonomous systems represent a major leap in AI development, where AI-powered machines can operate independently without human intervention. These systems are capable of sensing their environment, making decisions, and executing tasks autonomously. Tesla's autopilot and full self-driving systems exemplify autonomous systems in action. These systems leverage AI to navigate roads, avoid obstacles, and make real-time driving decisions with minimal human input. Despite advancements, autonomous systems face challenges such as safety, ethical considerations, and regulatory hurdles, particularly in high-stakes environments like autonomous vehicles. Number 9. AI and ethics, ensuring responsible AI. As AI systems become more advanced and integrated into daily life, ethical considerations have become increasingly important. Ensuring that AI operates within ethical boundaries, respects privacy, and avoids bias is critical for its widespread adoption and acceptance. Many organizations, including AI research institutions and tech companies, are developing frameworks and guidelines for ethical AI. For example, Google's AI principles outline commitments to fairness, accountability, and transparency in AI development. Ethical AI is crucial for maintaining public trust and ensuring that AI technologies are used responsibly and for the greater good. Number 10. Artificial General Intelligence, the final stage. The ultimate goal of AI research is the development of artificial general intelligence, an AI system that possesses the ability to understand, learn, and apply intelligence across a wide range of tasks, much like a human. AGI would not be limited to specific domains, but would have the cognitive capabilities to perform any intellectual task that a human can. AGI could revolutionize every aspect of society, from healthcare and education to science and technology. It could solve complex problems that are currently beyond human comprehension, such as climate change, disease eradication, and even the exploration of the universe. The development of AGI poses significant challenges, though, both technical and ethical. Ensuring that AGI aligns with human values and does not pose existential risks is paramount. Researchers are actively exploring methods to create safe and controllable AGI, but the path to achieving this remains uncertain. While AGI is still theoretical, recent advancements in AI, such as large language models, advanced robotics, and cognitive computing, suggest that we are inching closer to this reality. However, experts estimate that achieving AGI could still be decades away, requiring breakthroughs in areas such as consciousness modeling, reasoning, and common sense understanding. So, the journey toward AGI is a testament to the rapid and transformative progress in AI and robotics. Each stage of AI robot advancement has brought us closer to machines that not only perform tasks, but also think, learn, and adapt in ways that were once the realm of science fiction. As we approach the final stage of AGI, the potential benefits are immense, but so too are the challenges. Responsible development, ethical considerations, and global cooperation will be key to ensuring that AGI serves humanity's best interests. The future of AI is both exciting and uncertain, and the coming years will be pivotal in shaping the trajectory of this groundbreaking technology. And before you leave, if you haven't seen what's going on here in this video, man oh man do we have a good one for you.